Hi boys and girls, it's me Butch. My name is Terry David Silvercloud. I live in Vancouver, British Columbia, Canada. Today is Thursday the 17th of May 2018. I'm 73 years old and live alone. I'm a visual artist, photographer, and painting in my old age, and I'm really into theoretical physics. What didn't I cover? And yeah, I try to be useful in my old age, so I'm trying to spread my ideas and wisdom and whatever for anybody who wants to pay attention. I'm sort of a 24-hour-a-day art project, so I try to be entertaining. Today, my purpose is to do my best to explain to anyone who's interested, and a good scientist will always check everything out, my concept about the cause of gravity. And for any of you who are here and you think we know what causes gravity, it ain't so. We've been examining it for a few hundred years now, and we sure know lots of ways of measuring it and using it and anything you can do with it, but we don't know why it happens. Seriously, we don't. It's just like magnetism. We know pretty much anything you want to know about magnetism, except why does it happen? So these days everybody's beginning to accept the idea that there just has to be dark matter and dark energy, and how and why and when they might merge is a great big subject about which this is a bit of a part. And I go on and on like a dripping tap because I'm a bit ADHD, and I just wander off and seem to have every little descriptive detail that came along. I have developed over the last year or so a really good theory about how it is that a particle we call the electron is what sets the speed of light. It is both the cause and what actually makes it happen. And in this particular video I want to extend that, because it dawned on me that because it does all that I can just I can come up with a grand unified theory rather rapidly just based upon that idea. So in other videos I try to explain how it is that the electron sets the speed of light just by its characteristics, its shape, which I believe to be an icosahedron. That's what I believe the shape of an electron to be. And we already know that electrons repel themselves. We just know that. It's pretty easy to prove. It's being done every day. So we know electrons they don't like being with each other, and if you heat up a cathode in a vacuum tube, they'll be leaping out of their orbits like crazy, trying to just let me out of here. And then they're easily manipulated once you got them out of their orbits. Get some magnets on them and they'll just follow the magnets. But what are magnets? Magnetic motion must be the motion of dark matter energy. It is the magnetism, the dark energy, which is everywhere through us and around us. It all makes sense anyway. We can put magnetism through our bodies. So, and we know that the solid stuff is just not as solid as we seem to think it is. If you just accept that dark matter energy is part of the basic fabric of an infinite universe, and that Big Bang is just some silly creationist theory that I'm not going to waste time on today, I'll do that in another video, that the electron of the three major particles, the electron, the proton, and the neutron, is the generator of basically all energy by being the micro motor from within. Electrons are everywhere. They outnumber protons and neutrons together, and the reason I know that is a neutron will break down into a proton and an electron, so all neutrons are immediately out of the count, and that just becomes the electrons versus the protons. And just on that general concept alone, which is entirely logical, electrons outnumber all of the lepton, fermion, solid things out there, and might is right. When the gangs up, even if they're little suckers, they can be really powerful when the entire gang of zillions show up all at once. So where was I? Because I wanted to get something else in there and I don't remember exactly what it was. Yeah, I get strayed so easily. Anyhow, electrons. Jeez, I lost my track there. It's so easy for me to do. Let's get back to electrons. Electrons, I believe, are icosahedrons, and I believe they're structured from 20 smaller particles, which I call gamma particles. And the gamma particles take the shape of each of the 20 tetrahedra that make up the shape of the icosahedron, which I say is the shape of the electron. And we know for a fact, and I got straight off there somewhere, that electrons repel each other and they like getting away from each other. Oh, I remember what I wanted to mention just briefly while I was talking about electrons and protons. Because I was trying to remember, I lost what I was talking about, and I probably will again. You would think that an electron and a proton would just go schmuck and become a neutron, and they don't. Why is that if they're attracted to each other? Well, if you start thinking of the proton as being a torus, or even a triangular shaped torus, it could be fundamental. Its form, the smallest torus it could be, which would be a triangular torus, and has its weakest point a hole between it, or it's some sort of disc shape with its poles are somehow flattened. So if the electron is always repelling itself, it'll be looking for a place of rest. And a place of rest in a rushing ocean like the universe would be either in a hole somewhere in a proton or in a dip shape in it. So it could it's not so much being attracted to the proton as being pushed away by the gamma, the dark matter around it, which keep hitting it and keep hitting one of its or more of its 20 antennae exactly in resonance and pushing it around. So technically the dark matter, dark energy is trying to get away from itself at all times, and it can't. It's not so much exploding as the same as you see bubbles happening in an ocean. If you start thinking of the universe as an ocean and everything obeying laws of buoyancy, then all of this starts to make really good sense. And bubbles are only as big as they can be depending on how much pressure is on them. And if you start thinking of atoms as being more like Hoberman spheres, which have joints which can get larger or smaller depending on what sort of waves they have to deal with, other waves hitting them, all of which will either be electrons hitting them or the smaller gamma particles, which I say make up the electron. And we know for a bona fide fact, electrons repel electrons. They don't like each other. They're all bullies. And when you get a bunch of bullies together, the only way you can deal with a bully is another bully. And you get a lot of bullies together, the only way you can deal with a lot of bullies is to get another bunch of lottie bullies together. Then you got yourself a good old war. Where was I? So if you start imagining, and this is all my theory, and it just jives really neatly with everything, it doesn't require anything to change in what you already know, except that instead of thinking of gravity as an attraction to things, that's where I got off track again. We think the electron ought to be just peachy keen, happy to glide right into the proton and have a baby or something, but they don't. What happens when a proton and an electron meet up is they form a hydrogen atom. And from our perception and our model, somewhere around the nucleus, the proton, the single proton, is an electron. That fits in just peachy keen with what I told you. If the proton either was a torus or somehow was flattened at its pole because of its energy. When things spin faster and faster and faster and faster, they want to flatten out. So the most stable motion place on either side of such a torus or a pancake would be dead center on either side at the pole, because then you wouldn't have to go very far. You would be the singularity suddenly, and that's a kind of a rest, relatively. Did I get what I was going to talk about? I got all astray there. Yeah, so whatever happens, the electron never really does connect with the proton. It forms a stable relationship, and they don't do what the neutron does, somehow absorb it. They just become a hydrogen, and then because of the nature of motion, if you think of the single hydrogen atom as now being a pancake shape with an electron either above it, below it, or in the middle of it, it has a choice of spinning clockwise or counterclockwise, and physicists will, this is all rather basic physics when you start getting up there. Spin is just inherent. It can't be helped, and there's two. That's why the universe is dual and symmetrical, because there will always be either a left or a right spin, and there's no getting around it. There would be, where there's something, there's usually something else. So if there's one kind of hydrogen that takes an electron on one side, then there must be another kind of hydrogen with exactly the opposite. And it leads to, and it is in accordance with our observation, that one type of, I have a neighborhood crow who wants a handout, I think. So one atom of hydrogen would have a left spin, the other would have a right spin, and they could, by aligning up their spins, they could reduce their use of energy by simply pushing their feet together and joining up as a hydrogen molecule, which is what they do, which is H2, which would be 2 protons and 2 electrons. And they're quite happy to do that without even the need of a neutron. So anything I'm telling you conforms sort of to what we already know. Now, if you start thinking of the electron always looking for a place of rest from other electrons or from dark matter, which it is, it's just a stable form of dark matter of 20 of them, which are gamma particles. Or if you think of gamma particles being made of yet something smaller, it doesn't really matter. You know, it's like trying to search for God. You get to a point where is zero, and zero is relative to time, and time is relative to size. If you lived on a carbon atom, a second would be like your entire life. It's a really long time. So time, that's where Einstein got all confused, and I'm not going to waste time about where he got wrong and forgot Doppler effect. Einstein didn't think about waves. Einstein didn't think about Doppler effect. Einstein chose to ignore absolute motions and the fact that nothing ever goes in a circle. Everything is always a wave. There are no circles. Circles are a relativity illusion. You think you saw a circle, but you can only draw them on surfaces. There are no circles. In an ever-moving universe, it's just not possible, and you can check out some of my other videos about how the Earth moves through space, which is a helical wave with a period of 365 and a quarter days and a wavelength of about 7 billion kilometers. The wavelength of Earth is about 7 billion kilometers. And you are moving, as you watch this, and my nose is trying to clog up on me here, you are moving about 230 kilometers per second as I talk to you. I don't know why my nose is clogging up. Don't do that, I'm talking. Yeah, some kaffir here. So anyhow, if you start thinking about the electron as causing the energy of everything by trying to get away, gravity becomes push. Everything is trying to get away. So when things fall out of the sky, they're not being attracted to our planet. The planet is moving through space in a wave, and it's also spinning. And the place that is spinning the least is at the poles. So the best place, if you were trying to land on Earth, would be to, or any planet for that matter, would be to land at the poles, because then you wouldn't have to calculate for the Earth's rotation. And if you start falling from the equator, you're going to have to add the initial velocity of the Earth's rotation into your actual inertia. So you actually if you could already center yourself out at the pole, you would have less inertia, and it would be much easier to make landings at the pole than at the equator. But then again, if you wanted to go against the motion of the Earth, you might actually use the Earth's rotation to help slow you down, like a surfboard or on a wave, and the heat shields would have to be up, that's for sure. You'd be generating a lot of heat, you would. Anyhow, you can start seeing the electron as not only being the arbitrator of how information gets from here to there, like from your eye nerve cell electronically, one electron at a time, to the dude or girl sitting up in mission control in the captain's chair there. Nothing can get to your brain except by way of an electron anyway, and an electron has physical distance, and since we measure everything with measures, and we already have electrons and we're already using them but seem to not to be noticed, we're smashing protons and viewing them with electrons and ignoring the electrons that we're using all the time. The little electrons are the batteries from within. They're always on. They're always trying to get away. They're like the ultimate escape artist. You can't trust an electron. You can't leave those suckers alone. They're going to get out. Somehow they're going to get out. And that's probably why radioactive decay happens, is the structure. I view electrons as being the sort of the coaxial joints of the Hoberman spheres, which are atoms, and if one of those little suckers flies out, it's like losing a couple of teeth out of your flywheel or something. You know, things are going to go astray real quick. So radioactive material, if they start losing a few electrons here and there, which you call beta particles in radiation, and alpha particles, which are basically protons on the move, high-speed protons, if those things start spitting out, the whole atom falls apart, and they do. We call it radioactivity. But the two types of radiation are alpha and beta, and they are particles. So although we call them radiation, that's because when they get spit out at near light speed, and they're so tiny, they're like little bullets hitting you, and they're just going, you're getting hit by bullets, and not just one, but zillions. And they start snipping DNA, and they start, once they start snipping up your DNA, you're in real trouble. Everything they can start snipping nerve cells if you got hit by especially if a neutron flew out, which is basically an alpha particle. It just went kablooey, and you just got hit by a neutron, basically. So that's what radiation is, a breakdown of heavier atoms. And you can think of it as being the everybody's looking for rest. They're all trying to come to the center of rest, and the quietest place on Earth is the center of the Earth. It's the singularity that has to do the least. It's spinning on the pole. It takes 24 hours to do one turn, and it doesn't have to topple. So it's the point of rest, and everything's trying to be there, but it can't because there's matter in the way, and the solid stuff gets to be close to the center, and the liquid, and the airy stuff. And it takes a lot of energy to be airy, but it's still there. But if you imagine dark matter and electrons pushing everything into areas of rest, then you should be able to see my view of how electrons, not only because they repel themselves and everything around them that's smaller than them. Oh, I don't think I showed you that. So if you imagine, this is an icosahedron. I just don't happen to have an icosahedron, but it's an electron, and it's made of 20 tetrahedra with tetrahedrons, which are this is going to be a tetrahedron, this black ball. So if you're a dark matter or gamma particle, you're not big enough to push an electron out of the way. This is your big brother, and you're the kid brother, and big brother is going to decide who's boss, and that's not going to take very long, unless the little one's smart. So the little one, because it has a surface exactly the same as one of the surfaces here, exactly the same, it's a triangle, and it can join itself right onto one of the triangles. It could fairly easily roll if it had some of its buddies pushing behind it, it could cause the electron just to roll, and that would be good enough. The dark matter, dark energy could just flow around whichever way the forces were greatest around the electron, and all the electron would have to do is lift out of the way or spin, which is pretty much exactly what they do if you think about it. So it doesn't really matter whether you think about the electron as a sphere or as an icosahedron in terms of motion, but in fact, to be most efficient would be to have 20 tetrahedral antennae facing in every which direction, which were exactly the size of the next smallest particle, which took the shape of a tetrahedron. And we could easily assume, or I'm saying so, that that is a gamma particle. And the gamma particle may and well be composed of yet smaller particles, but from our point of view, it's really the limit at which we can deal with size and time until we can manage devices which can scan in 3D gamma rays and not kill us while it's doing it. Because if gamma rays hit you, you're you're dead real quick, and it might be in a nasty way too. So how long have I gone on? 21 minutes. I talk a lot, and this is all my theory, how the electron sense the speed of light. I'm 73, I think I told you that. I was a naval officer when I was age 19 and navigated HMCS Cape Scott, and I went into submarines, and I served aboard HMS Tiptoe, HMS Opportune, and HMCS Ojibwe back in 1967, 1968. And then I left the Navy in early 1969 because I'd signed up for 7 years. The Navy and I decided I wasn't going to stay, and they didn't want me if I wasn't going to stay, and we came to an agreement, and I left. And I did a whole lot of other things and never really got around to doing the physics I thought I was going to do. And I got back into it in 2004 when I started asking myself how fast one would have to be here and there and there and there at the same time, which is 4/3 pi c cubed for any given amount of time. And that time is relative to how big you are. A second is light speed. The speed of light is just slightly less than 1 foot, about 29.9 centimeters in 1 billionth of a second. In 1 nanosecond, light only goes about that far. So once you get being on atoms, like in your shirt or in your fingernail or, I don't know, somewhere, atoms are really small. So by the time you get down to being that size, even a foot when you're in an atom is like a long way. I mean, really a long way. So Einstein, I don't think, got into wrapping his mind around the relativity of size and time. And he ignored Doppler effect. And he ignored waves when he was first thinking about these issues with light and the speed of light. And I'm just trying to sort them out now by offering you an explanation that is so darn logical that once you start wrapping your mind around, you say, geez, why didn't I see that? And to tell you the truth, I don't know why I saw it. It wasn't what I went looking for all those years ago, and it just kept haunting me because I'm the kind of person that likes to know everything about everything, and I'm a devout atheist, so I want to be able to look behind the mask of God and prove that it's totally empty. This is it, kid. Do the best to be somebody in this life, because as far as I can tell, this is it in this reality. Time is related to size. How big is big? How small is small? How fast is fast? How slow is slow? When you start asking yourselves those questions, your mind will turn to rubber at first, but if you follow some of the concepts I try to teach you, start thinking of reality as being infinite, and you're just seeing it from a particular size and time relationship over which you have no control. But you can look out there and you can sort of get visions of how reality is having its storms on a colossal scale that take millions and millions and millions of years. And then what becomes important to us is, like, you know, am I getting any, or do I have a roof over my head, or can I pay the rent? Those kind of issues. Really, you know, there's so much to deal with, like what is real and what isn't real, and I have no idea what life is about, but I'm certain it's looking after itself, and I'm doing whatever. I feel self-realized that this, if I think of something that I have no idea what happened, is certainly not from God, but it may be there's something going on that I don't understand about this reality, and because some of the ideas that come to me, I just don't understand how they came to me, except that I thought about them for a whole long time. So I'm up to nearly 26 minutes. My nose is clogged. I hope I'm not getting a cold. Can't be. Am I on? I'm on. There it is. So I'm going to say goodbye. This is Butch in Vancouver. You can check out my other videos. Bye-bye.